After studying this module, you shall be able to review the concept of correlation and coefficient of correlation, understand how direction and magnitude of correlation coefficient tells us the extent to which variables are correlated to each other. Learn to calculate Pearson product moment correlation. Review the concepts of simple regression and multiple regression. Learn to compute the probable value of variable x or y by using regression equations. And finally, understand the importance of correlation and regression in drawing inference making predictions in psychological assessment. One of the main necessities for psychological testing and assessment is to examine the relationship of one variable to another variable, that is x to y. For example, a researcher is generally interested in finding out how certain traits, abilities, attitudes and interests are related to the behavior of people or group of people. Statistically, relationships of one variable to another can be found by using coefficient of correlation, represented by small r. Correlation describes the direction and strength of the linear relationship between corresponding variables. Closely related to the concept of correlation is prediction. If two variables are correlated, then from a person's score on one variable, a prediction of score on the other variable can be done. In general, the greater the correlation between the two variables, the more accurately the prediction on one variable can be done on the basis of the score of another variable. Regression is the statistical tool with which the relationship among variables can be analyzed for the purpose of understanding how one variable may predict another variable. Thus, correlation and regression are concepts central to the study of tests and measurement. In this module, we will comprehend the concepts of correlation and regression and how they are applied to psychological assessment.
Let's start with the concept of correlation. Instead of measuring the performance, ability, trait of a person on a single variable, researchers are generally interested to know how variables relate to each other. For instance, a researcher might be interested in knowing the kind of relationship that exists between intelligence and creativity, or anxiety and academic performance, or organizational culture and job satisfaction. The answers to these questions can be found with the help of a statistical measure termed correlation. Correlation helps us to determine the amount of relationship between two or more variables. However, it does not ensure the cause and effect relationship between variables. According to Connor, if two or more quantities vary in sympathy so that movement in the one tend to be accompanied by the corresponding movement in the another, then they are said to be correlated. Boddington has defined correlation as whenever some definite connection exists between two or more variables, there is said to be correlation. It does not matter whether the data in one section changes in the same direction or in the reverse direction to that in the other. The definition, however, does not refer to the fact that correlation shows the degree of closeness of relationship between two or more variables. The concept will be more clear when we will now study the types of correlation. If two quantities vary in such a way that change in one is accompanied by change in the other, these quantities are said to be correlated. Correlation in its general sense means that between two series or groups of data, there exists some association or relationship. Let's consider an example. Suppose a researcher is interested to know how anxiety levels affect academic grades in the school children. Correlation analysis can help him to know the amount of relationship that exists between variable x, which is anxiety level, and variable y, which is academic performance. See the three tables given below to show three possible kinds of relationship that may exist between variable x and variable y. The data in table 1a indicates a positive relationship or a positive correlation between variable x and variable y. It means that the higher score on the x is paired with the higher scores on the y, and the lower scores on the x is paired with the lower scores on the y. In other words, increase in the level of anxiety is associated with increase in the level of academic performance and vice versa. The pairs in positive correlation vary together in a linear positive manner. A positive correlation exists when two variables simultaneously increase or decrease as depicted in table 1a. Now see the data in table 1b, which shows a negative correlation between variables x and y. This means that the higher scores on x are paired with the lower scores on y, and lower scores on x are paired with the higher ones on y. A negative correlation occurs when one variable increases while the other variable decreases. Thus, it means that with the increase in the level of anxiety, the level of academic performance of school children decreases. Or, in other words, as the level of anxiety decreases, students' academic performance increases. Now consider the data given in table 1c, which depicts a zero correlation, meaning no consistent pattern of relationship between two variables of anxiety and academic performance. High and low values of x are equally paired with both high and low values of y. After understanding the three types of correlation, now let's see what is the coefficient of correlation. The degree of correlation is measured by the coefficient of correlation and is represented by small r. It is a ratio which expresses the extent to which the changes in one variable are accompanied by the changes in other variable. In other words, it is the numerical index that tells the extent to which two variables x and y are correlated. The coefficient of correlation indicates the direction and magnitude of relationship between two variables. It is a ratio which expresses the extent to which the changes in one variable are accompanied by the changes in the other variable. In other words, it is the numerical index that tells the extent to which two variables x and y are correlated. Let's understand the direction and the magnitude of relationship between the two variables. The coefficient of correlation indicates the direction and the magnitude of relationship between two variables. The direction of a correlation coefficient is interpreted by its sign. Positive sign indicating positive correlation or negative sign indicating negative correlation. The magnitude is represented by the absolute value of correlation coefficient, with greater absolute value implying greater degree of relatedness. A correlation coefficient can range in values from -1 to +1. When there is a perfect positive relation, the value of R is equal to +1. In case of perfect negative correlation, the value of R is -1. These two values are the extreme limit of R representing perfect positive and perfect negative correlations. Perfect correlations in psychological work are difficult to find. In most actual problems, calculated R falls at the intermediate numerical value of 0.62 minus 0.89 plus 0.45 etc. Such R are interpreted as high or low depending in general how close they are to plus 1 or minus 1. The degree of correlation will be 0 if there is an absence of correlation. Let's study the broad categories of the degree and direction of correlation with its meaning. The perfect positive and perfect negative correlation is represented by plus 1 and minus 1 values. Very high correlation is represented when the value ranges somewhere between 0.75 to 1, applicable for both positive as well as negative sign. Correlation is said to be high when the value ranges between 0.50 to 0.75. It is said to be low when R value is somewhere in between 0.25 to 0.50. Very low correlation is reported for values of 0 to 0.25, and the value of R equals to 0 represents absent or no correlation between the two variables. Let's understand correlation and causation. Correlation should not be confused with causation. It is to be noted that correlation coefficient indicates the degree of relationship between the two variables of interest. It does not imply that they exhibit cause and effect relationship. Even if a high degree of correlation exists between the variables under study, it does not mean necessarily that a relationship of cause and effect is present between them. The explanation of any significant correlation is any one or a combination of the following three reasons. The first reason says that the correlation may be due to purely a chance, especially if a small sample size is taken into consideration for the study. Such a correlation may arise either because of pure random sampling variation or because of the bias of the investigator in selecting the sample. The second reason explains that both the correlated variables may be influenced by one or more other variables. It may be possible that there is a high degree of correlation between the variables due to some causes affecting each variable or different causes affecting each with the same effect. The third reason could be that both the variables may be mutually influencing each other so that neither can be designated as the cause and the other the effect. Students, let's understand how to calculate correlation coefficient. Carl Pearson coefficient of correlation, also known as Pearson product moment correlation, small r, is the most widely used of several alternate measures of correlation. It is generally used when the relationship between the variables is linear and continuous in nature. Formula for calculating Pearson is depicted here, where n is the number of pairs or scores, sigma xy represents sum of the products of paired scores, sigma x is the sum of x scores, sigma y is the sum of y scores, sigma x square is the sum of squared x scores, and sigma y square is the sum of squared y scores. Let's calculate an example to understand. Given here is the table with the values of variables x and y, where variable x represents anxiety level and variable y represents academic performance. The third column depicts the x square value. The fourth represents y square, and in the fifth column variable x and variable y are multiplied, represented as xy. the total number of cases n is this case is 6. Sigma x is 63, sigma y is 45, sigma x square is 819, sigma y square 355 and sigma xy is 420. Applying the formula of Pearson given above, the value of R came out to be, applying the values in the formula given above, the calculation of correlation coefficient R in this case is -1. Thus, there exists a perfect negative correlation of -1 between variables x and variables y. Let's test the significance of correlation. It is important to test the significance of correlation, otherwise it may not be possible for the researcher to know that whether correlation computed by him or her is having any significant meaning or not. In other words, it is important to know whether the obtained correlation coefficient represents a real correlation or merely a correlation obtained due to chance. For this, table of significance for Pearson R is consulted. A significant at either the 0.01 level or the 0.05 level indicates that result could have been expected to occur by chance alone 5 times or less in 100. It provides a basis to conclude with confidence that a correlation does indeed exist. To calculate significance of correlation, first degree of freedom is calculated, which equals to 2 less than the number of pairs for which correlation coefficient is computed. So, if data is collected from 30 pairs, degree of freedom will be n-2, that is 28. Next, for the given degree of freedom, critical value table for Pearson correlation is consulted to see the intersection value of degree of freedom with alpha levels of 0.05 and 0.01. If the calculated value of correlation coefficient is greater than the critical table value, it signifies a statistically significant relationship between the variables under study. However, if the calculated coefficient is less than the critical table value, it signifies a non-significant relationship between the variables. A Pearson R of 0.899 with an n is equal to 10, significant at 0.01 level, critical value is 0.78 at 0.01 level. It tells that significant correlation exists between the studied variable. It confirms that with reference to the data given, the correlation is expected to occur by chance alone 1 time or less in 100 if x and y are not correlated in the population. I hope you have now understood the concept of correlation and its test of significance. Now let's move on to what is regression analysis. The word regression refers to an act of returning or going back. Once a researcher establishes correlations between the two variables, it becomes necessary to know the extent to which one variable varies in response to a given change in the other related variable. Regression is a statistical tool with which a researcher reveals the nature of relationship between the two variables and determines the average probable change in one variable when a certain amount of change in the other is known. Therefore, with the help of regression, a researcher is in a position to estimate or predict the unknown values of one variable from the known values of another variable. This is done with the help of regression lines and regression equation. Regression line, which graphically describes the average relationship between the two variables, refers to the graphic method of regression analysis. For variables x and y, we shall have two regression lines. The regression of x on y indicates that the most probable value of x for the given value of y. The regression of y on x gives the most probable value of y for the given value of x. The perfect correlation between x and y with r value nearly equal to +1 or -1 will make two regression lines coincide and overlap each other. Let's now see what are regression equations. The equation which describes the line of regression mathematically is known as regression equation. The regression equation of y on x is represented as y is equal to a plus bx, where a and b are constants called regression coefficient. B is equal to the slope of line and a is the intercept. Similarly, the regression equation of x on y is expressed as x is equal to a plus by, where b is equal to the slope of line and a is the intercept. The values of a and b are calculated from simple algebraic calculations using the formula y is equal to na plus bx and xy is equal to ax plus bx square. From these two equations, we can compute the most probable values of x for the given values of y or the most probable values of y for the given values of x. Let's see the difference between the simple regression and the multiple regression. Simple regression involves one independent variable x, which is typically called as predictor variable, and one dependent variable y, which is called criterion variable. Regression analysis, which involves one independent and one dependent variable and results in a single equation for a regression line, is termed as simple regression. The statistical technique of regression analysis helps in finding out an average of relationship between variables, related observations in the form of a regression. Multiple regression is an extension of simple regression. It involves many predictor variables and a criterion variable. The use of more than one scores to predict y requires the use of a multiple regression equation. Multiple regression takes into account the intercorrelations among all the variables involved. The correlation between each of the predictor score and what is being predicted is reflected in the weight given to each predictor. Regression coefficients, referred to as beta values, are calculated between each predictor and criterion variable, and more weightage is given to those predictor variables which correlate strongly with the criterion variable. Students, the value of regression coefficients these days are computed with the aid of statistical softwares like SPSS and AMOS, which also test the levels of significance of correlations. After studying the concepts of correlations and regression, now let's see the application of the two in psychological assessments. Correlation, simple regression and multiple regression are essential statistical tools to find relationships among variables and to draw inferences or make predictions from the test data. The two concepts are widely used in many areas of psychological testing and assessment. Let's discuss some of these areas. Within the classical test theory, correlation is widely used in various steps of item analysis of test construction. The discrimination index of an item is calculated by correlating the score of each individual test item with the total score on the test. This helps a researcher to know how an item relates to the total test score or item, which is called as item total validity. Correlation also identifies the inter-item relationships, which establishes item reliability of a scale. If a scale is comprised of items that are homogeneous in nature, the items will have high intercorrelations. On the other hand, a scale containing mainly heterogeneous items will show low inter-item correlations. In such a case, the items will show varied levels of correlation with other variables of interest or study. Reliability of a psychological test, that is, the consistency in test scores over repeated administrations, is also established by computing coefficient of correlation between the scores on initial performance with performance on the same test at a subsequent time. While constructing and standardizing a psychological test, differential item weighting is done when items are assigned weights as per their contribution to the total test score. The reliability of each item is calculated and items with higher reliabilities are supposed to contribute more weight in the total score. Both correlation and regression are used to assign weight and calculate differential item weighting. Last but not the least, correlation and regression are also used to establish test validity, that is, the extent to which test measures what it is intended to measure. Consider an example in which a researcher wishes to know the extent by which scores on a speed test is predictive of on-the-job performance as a typist. Knowing the degree of association and prediction between the two variables would help a psychologist to do her job effectively. Both correlation and regression are widely used concepts in test construction, test standardization, psychological testing, and assessment. The two are widely used in various stages of scale development. This module provides a brief review of the two concepts. Let's summarize what we have discussed. The concepts of correlation and regression are reviewed in the module. Correlation determines the degree with which the two variables are associated to each other, and regression predicts an individual's position in one variable when position on another variable is known. The Pearson product moment coefficient of correlation is the most widely used numerical index that determines the degree of correlation between two quantitative variables characterized by a linear relationship. The sign of coefficient tells whether the two variables are positively or negatively related. The magnitude of the coefficient varies from 0 when no association is present to +1 and -1 when the correlation is perfect. Correlation between two variables does not specify cause and effect relationship between them. Talking about regression, like correlation, it is an analysis of linear relationship between variables. If two variables are linearly correlated, the knowledge of scores on one variable can be used to predict scores on other variables with the help of regression lines and regression equations. Simple regression is characterized by one predictor variable, which is the independent variable, and one criterion variable, which is the dependent variable. In contrast, multiple regression, there are more than one predictor variables and a criterion variable. Simple regression is characterized by two regression equations and thus two regression lines, one for predicting variable y from variable x and the another for predicting variable x from variable y. Last, we also considered how during scale development process both correlation and regression are used in establishing the reliability and validity of test items and test as a whole. Thank you.